For decades, we have all heard the same story. A cosmic collision is coming, the Andromeda Galaxy is hurtling towards the Milky Way, and they're doomed to crash in a spectacular, terrifying galactic pileup. But what if that dramatic forecast was wrong? New evidence has surfaced that flips the script on everything we thought we knew. The epic collision we have been bracing for, it might just be a cosmic coin toss. This is not a small tweak to the story. It's a complete rewrite of our galaxy's future, forcing us to ask, what really happens at the end of the line? For over a century, the story of impending doom has been pretty solid. Ever since astronomers noticed Andromeda was blue shifted, a fancy way of saying it's rocketing towards us, the collision felt like a sure thing. Our galactic neighbor, about 2.5 million light years away, has been clocked moving in our direction at a blistering 250,000 miles per hour. With that kind of velocity, a crash seemed like simple physics. In 2012, astronomers using the Hubble Space Telescope basically sealed the deal. After carefully tracking the sideways motion of stars in Andromeda, they concluded it was so small that a head-on collision was all but guaranteed. They even gave us a timeline. In about 4 to 5 billion years, the two galaxies would meet. The predictions were mind-blowing. Andromeda, packing 1 trillion stars, would dwarf our Milky Way's 300 billion. The clash would not be like two cars crashing. Galaxies are mostly empty space, so stars hitting each other would be incredibly rare. Instead, it would be a celestial ballet, a slow-motion merger directed by gravity over hundreds of millions of years. Simulations painted a wild picture of this galactic dance. The first pass would stretch and warp both galaxies, flinging their beautiful spiral arms into chaos. This gravitational tango would squeeze huge clouds of gas and dust, setting off a brilliant burst of new star formation, a cosmic firework show lighting up the heavens. Our night sky would be transformed, with Andromeda growing bigger and bigger until it filled our entire view. Eventually, gravity would pull the two galactic cores together. They'd merge, and the stars from both galaxies would settle into new, random orbits, creating a single giant elliptical galaxy, a new home nicknamed Milky Way. And what about us? The outlook was a little shaky. While Earth would not be smashed, the Sun could get slingshotted into a new, distant orbit, or worse, booted from the new galaxy entirely, left to drift alone in the intergalactic void. This story of guaranteed collision was astronomy gospel for years, as inevitable as death and taxes. But it turns out the universe is a lot messier, way less predictable than we thought. The story started to unveil thanks to insanely precise new data from the European Space Agency's Gaia mission, launched in 2013. Gaia's whole job is to build the most detailed 3D map of stars ever, tracking their positions and movements with mind-boggling accuracy. When astronomers plunged this new Gaia data into their simulations, the results were jaw-dropping. The Grand Collision, once a near certainty, was downgraded to a 50-50 shot. According to new research, there is only about 50% chance the Milky Way and Andromeda will actually merge in the next 10 billion years. As one research put it, proclamations of the impending demise of our galaxy seem greatly exaggerated. So what changed? Why were the old predictions so confident? It all comes down to the chaotic mess of our cosmic neighborhood, the local group. Earlier models mostly focused on the gravitational tug-of-war between the Milky Way and Andromeda, but they are not alone out there. The new simulations were powerful enough to include the gravitational pull of smaller but still hefty satellite galaxies. Two cosmic wingmen turned out to be game changers: the Large Magellanic Cloud LMC, which orbits the Milky Way, and the Triangulum Galaxy, Andromeda's companion. It turns out these smaller galaxies are like cosmic puppeteers. Their gravity subtly but significantly tweaking the paths of the two giants. The models showed that the LMC's gravity actually decreases the odds of a merger, while Triangulum's gravity increases it, When you factor in all these new variables, the one certain outcome becomes a statistical coin flip. The probability of a detect hadron is the next 4 to 5 billion years that plummeted to less than 2%. The story of our galaxy's fate was no longer a straight line but a tangled web of maybes. And this is what makes science so cool, right? What we think is a fact one day can be completely upended by new data the next. It's a process of refining, of getting closer and closer to the truth. And it's what makes following discoveries in astronomy so thrilling. If you find this chase for answers as fascinating as we do, make sure to subscribe and hit that notification bell so you don't miss our next trip into the cosmos. Okay, let's say the coin lands on heads and the collision is a go. The timeline is now pushed back. Instead of 4.5 billion years, the merger would likely kick off in 7 to 8 billion years. The process would look a lot like the class U models predicted, but our understanding is a bit more defined now. The first pass would still be a spectacular galaxy bending one. From a hypothetical future Earth, the view would be insane. Andromeda would hang in the night sky, a permanent, dazzling fixture. The tidal forces from this closed shape would spark furious bursts of star formation, creating brilliant new blue stars across both galaxies. But even in this collision scenario, it's more of a slow gravitational hug than a demolition derby. The sheer emptiness of space means the stars themselves would not smash into each other. It would be a ghostly passage where gravity is the main artist, reshaping everything. Eventually, the two supermassive black holes at the center of each galaxy would start a cosmic wars, spiralizing closer until they merge and release an unbelievable amount of energy. The end result is the same, a new, massive, and more globe-like elliptical galaxy, Milky Way, a giant ball of aging stars. The fate of our solar system is still up in the air, with possibilities from being nudged into a wider orbit to getting ejected entirely. But for humanity, it's kind of a moot point. In a 5 billion years, our sun will have already started dying, swelling into a red giant that will likely scorch the earth and boil our oceans, making our planets uninhabitable long before the galactic merger gets going. Now for the other side of the coin, the 50% chance that the galaxies don't collide. What does a near miss even look like on a galactic scale? In this scenario, the Milky Way and Andromeda would not merge, at least not in the next 10 billion years. Instead of crashing, they'd fly past each other in a close encounter. They'd still get close enough for gravity to do its thing, losing a bit of energy in the process, which might cause them to swing back for another pass millions or billions of years later. This would be less of a dramatic merger and more of a long swirling dance. The galaxies might trade a few stars and their outer edges might mingle, but their core spiral structures would stay mostly intact. Our view from Earth would still be spectacular as Andromeda swells in the sky, but our own galaxy would keep its familiar shape. This outcome shows just how sensitive those cosmic forecasts are. A tiny change in mass, a slightly different path for a satellite galaxy, and the entire future of our local group changes. The fact that a miss is just as likely as a hit reveals we live in a universe governed by a delicate balance of forces, where the future is not written in stone. So, were scientists just wrong about the galaxy collision? Yes and no. The original predictions were solid, based on the best information they had. But science is not about being right all the time. It's about getting less wrong as we get better tools and more data. The story of the Andromeda Milky Way collision is a powerful reminder that our cosmic playbook is always a work in progress. For decades, we were told a story of inevitable destruction and rebirth. Now, we have a story of cosmic uncertainty. Our galaxy's fate is hanging in the balance, a 50-50 chance between a spectacular merger and a graceful flyby. The final chapter has not been written yet. As missions like Gaia keep collecting data, the picture will get clearer and our cosmic forecast will be updated once again. This ongoing mystery is not a failure of science, it's the very heart of it. What do you think about this new uncertain future? Is a near miss more or less exciting than a full collision? Let us know your thoughts in the comments below.